Hello, everyone. Welcome to the podcast series of HCLTech Aerospace and Defense. Myself, Anshul Sharma, Industry Principal for A&D, and today I have with me Mr. Sounder Rajan, Head of our Model-Based Systems Engineering in HCLTech Engineering and R&D Services Unit. And today, Sundar is going to talk about model-based systems engineering and specifically some of our capabilities in this area and the work we have been doing for some of the A&D companies and as well as companies in other manufacturing sectors. So welcome, Sundar, to the podcast, and great to have you here.
Namaskar, and thank you, Anshul. Thank you for this opportunity and having me on the podcast. So it's a pleasure, and also providing me an opportunity to share my views and thoughts on MBSE as a system engineering practice and its current state as viewed at HCLTech from an aero and defense industry context. It's very nice to be part of this podcast. Thank you.
So welcome, Sundar. And as you know, in one of the earlier podcasts that I did on model-based enterprise 2.0 with Mr. Roy Davis, we spoke about the concept of MBE 2.0, which focuses on integrating the digital thread across the extended enterprise and not just product-centric functions like engineering or manufacturing. But today I want to specifically focus on that engineering digital thread, and within engineering, specifically model-based systems engineering. So maybe could you start with providing a background on MBSE, what makes it essential for A&D industry compared to other traditional systems based engineering methods? And also, as you know, like MBSE concept has been there since quite some time. So how do you see it evolving, over the past few years and in future?
Yeah, thanks, Anshul. That's a great question. And then probably I'll just start off with setting the context a bit, and then probably we can just go into the aerospace and defense. So just as a background, a very short summary, just to give a brief intro to what MBSE is. MBSE obviously stands for Model-Based Systems Engineering. And it's an alternate technical approach to systems engineering that focuses on creating and exploiting domain-specific models as a primary means of information exchange rather than a document-centric approach, which is what the traditional way to system engineering has been. So there's been a practice that's of a fairly recent origin, at the same time not too new. So just to give some context, the term MBSE, just to give the right credit, there's a book by Wayne Wymore, back in 1993 when he had a book by the name MBSE itself, and that's where these concepts were theorized and also captured in a book. And then subsequently, around 2003, 2005 is when the OMG group also actively started working on the SysML as a subset of the UML language thing as a methodology. And it also started using or basically evangelizing the term MBSE there. It became a little more popular there. And also in 2007, Incourse also adopted in their charter and also wanted to institutionalize this as a system engineering best practices, adopting the model-based engineering. So this is sort of the background on how these things have evolved. And from 2007 onwards, there have been a few pioneers in this field who have adopted this as a practice. And especially in this context, the aerospace and defense industry has been a leader in sort of adopting this and then piloting this. But the fundamental idea is that the model is the only single source of truth, and all other things like be documentation or a trace that is required, configuration, control, and all those things, which are part of the regulatory aspects, is built around the model as a single source of truth. So it's very important in regulatory and safety critical industries that the integrity of the lifecycle data is sacrosanct. And also you have threads that can go up and down through the multiple discipline chains of the requirement, elicitation, capture, design, decomposition, and development process throughout the life cycle. So that's the need. So that's where MBSE ties in neatly into the digital thread concept, in the sense that you have a wide ecosystem of tools across the multiple disciplines, and all these things have to really come together to give a seamless experience. So that's the connection between adopting MBSE as a methodology and as a process, and then the digital thread coming in and providing the context of basically providing the configuration control, the version control, and traceability and maintainability of the data with respect to the life cycle of the product, subsystem, or system in complex systems that are to be engineered. So that's just a brief background on the MBSE. And coming back to the aerospace industry, why were they the early adopters? Actually, if you just look at this, usually aerospace systems are pretty complex and they are multidisciplinary. And also on the commercial or manned airplanes, the safety criticality aspect need not be overemphasized. It's just mandatory and also a regulatory need. So given this background, and also with some of the traditional challenges in the traditional development cycle where maintaining traceability, and then when issues come into it, and then the links become suspect, and all this maintaining and evidencing this to the regulatory authorities, as well as it impacts the quality of the product itself. So that was a challenge in the traditional approach of document-centric systems engineering. So what model-based systems engineering does is it provides you a simulation approach to basically model your requirements, check the feasibility of it, also push some of the validation to the left, or what we call a shift left philosophy, which provides an early opportunity to model your requirements, simulate them, check the feasibility of it, uh, find out any issues in the requirements, go back to the customer and basically close them out early, and also find out any safety related impacts that can be simulated from the regulatory compliance aspect. So this early issue detection, enabling compliance to regulatory needs like establishing the trace links across the disciplines and across artifacts that are managed in the system engineering lifecycle, along with the ability to collaborate across disciplines, which in a document-centric thing is very, what do you call, not interactive in the sense that you can't see some dynamic simulation of something and then see, okay, do some what if scenarios. So that also is a powerful enabler in the MBSE context. And it also allows for evolution of the complexity and then see how the system evolves. So it gives you handles to efficiently handle the complexity. And you can really go in from a low fidelity, medium integrity kind of a simulation scenarios all the way up to the high integrity, high fidelity simulations, which are finally the actual design aspects that go into a product. So it gives an evolution path. And then these are some of the key aspects that the MBSE practice actually to system engineering enables vis-a-vis the traditional engineering. So that's just a background on the aerospace and defense industry's adoption of it, and also as you know, the ecosystem as OEMs, tier ones, tier twos, and all these need to exchange this data and collaborate. So MBSE with its standards-driven approach sort of enables this ecosystem and then uh, brings in productivity and efficiency improvements into the aerospace industry ecosystem.
Sure. So you mentioned about bringing in productivity and efficiency. So given some of these advancements that have been happening in MBSE over the last few years, so how do you think MBSE is helping A&D and other manufacturing companies reduce costs and development time? Because that is the main kind of one of the key goals of the product development teams to accelerate the product life cycle, reduce the time to market. So how do you think that is helping in reducing those costs and the development time?
Yes, this is a very relevant question and the industry need also. And just to set the context, actually, a recent survey related to the adoption of this practice across industries and what are the benefits of this have been published in few papers and studies, and also in some of the in-course seminars. And I would just like to quote some of the data points from one of the studies. Where it was found that around 44% of the active industry adoption across in the MBSE practice is led by aerospace, defense, and around 17% of it is from the government side. So if you look at 100% wide pie of MBSE practice across industries, so aerospace and defense and government takes around 55 to 60% of the pie. And that's an indication of, because these industries are very complex, right from the subsystems to their systems and system of systems in terms of integration, design, the whole product's maintenance, life cycle, production, and field. That's a complex engineering life cycle as far as aerospace ecosystem is concerned. And this MBSE practice over the past 10 years across different industries have given clear data points which show that it has helped in early detection of design issues, especially either in new product life cycles or products that have migrated from a document-centric approach to MBSE kind of a practice. So in both of them, there have been efficiencies in early detection of design issues, which in the traditional approach would have come late in the life cycle, like after the hardware has been developed or the software has been designed, and then you find issues, and then you go back to the left side of your system requirements life cycle. That's a huge cost. So that shift left philosophy has been proven in practice, and that's definitely a big differentiator. It allows early detection of design issues. And the other thing is improved collaboration. So if you look at model-driven engineering, that's not a new thing. It's been there in the industry from the past 20 plus years. That's not new. But what was happening even earlier was that it was still document centric. So let's say a mechanical engineering discipline or a software engineering discipline or a hardware electronics or a firmware discipline would still get their textual requirements, and they would be siloed with their textual baselines, and they would not interoperate with each other seamlessly. So they would remain siloed, and also the integration challenges won't come to the fore earlier. But now, whereas what has happened is, with the digital thread and the capability of PLM adapters, so you are able to actually integrate the system engineers simulation models with the high definition simulations from the respective other disciplines, let's say from mechanical engineering with their 3D designs or their performance analysis or the thermal analysis that they may have done, that can be integrated with the requirements, and then see what's the performance constraints as a system engineers have constrained them, and what is the actual simulation and analysis of the performance that they are able to achieve. And same thing applies to the software side. When you have a controls or a communication interface being implemented, you can just see that what are the data interfaces, how does the control function interact with the system or the system of systems, and does it meet the performance from a timing aspect or availability aspect, and all those, and even simulation of redundant scenarios, so which are all a key need. So these kind of collaboration scenarios were really not possible in a document-centric approach, and the model-driven designs in the respective discipline used to be siloed. But now with kind of a cyber-physical modeling and early system simulation from various disciplines, you can do cross simulation with the different things across the multiple disciplines. So that improved collaboration is another differentiator that comes from the MBSE practice. And simulation and testing in the virtual space. As you know, the regulatory need, because of the regulatory need, and also the cost of building safety critical systems is high, both from a hardware fabrication and also the software. So if you can do all this upfront in a virtual space, it one saves you a lot of lead time in terms of really realizing or virtualizing and seeing how it behaves, and also doing the behavioral simulation and modeling, which would, in the traditional approach, would have meant you go down the cycle, fabricate it, and then when you integrate and put these things together, you find issues. So this sort of helps find out major issues to be de-risked upfront, or any complex kind of integration issues to be foreseen and de-risked earlier. So that doesn't mean that there won't be any issues found lower down the life cycle. That would still be there, but this actually improves productivity and also de-risks or provides a mitigation path for these kind of issues, which would be very costly in the traditional cycle. And also the other important thing from the digital thread is, when these safety critical subsystems or systems that have been developed, they have to actually evidence traceability, configuration control, and version control and part control. in a very integrated way. So when you set in through audits or you go through the regulatory authorities, you need to evidence this. And what the digital thread does is it ties in all these ecosystems neatly and then sort of gives you a digital thread of, okay, if this is a customer requirements or a regulatory requirement, how does it flow down from the requirements onto a logical decomposition in the system area, and then onto the physical areas into the respective multiple disciplines. And the bigger important thing is they can also see that, okay, if a requirement is changed, so what's the impact on the other systems and subsystem disciplines throughout the life cycle. So the digital sort of enables the suspect links and the impacted links with an easier and better insight than a document-centric thing, simply because the model is at the center of the truth and that reflects the actual implementation that's realized.
Okay.
So I think these are some of the advancements and also benefits that accrue from the adoption and practice of MBSE.
Sure. So based on some of these data points and the benefits that you highlighted, it's evident that MBSE is bringing in, a lot of cost advantages in terms of savings as well as, faster product development life cycle. But for an industry like aerospace and defense, which operates under strict regulatory requirements as well as security standards, uh, transitioning to a model-based approach isn't as easy. So what do you think are the most important challenges for these companies in adopting MBSE, and how can they be overcome?
Yes, you just rightly hit the nail on the problem, and then that's exactly the thing that the industry has to deal with, because
Mhm,
it requires a cultural shift.
mhm,
If the majority of the workforce is used to a traditional document-centric approach, even though they have been using model-driven design or model-driven engineering, the primary source has still been document-centric thing. So it needs a complete cultural shift, right
yeah,
from the leadership to the engineering leadership also, and even the corporate leadership, as well as the team members who are actually building the products across the disciplines, and especially the system engineering teams who are responsible for the system engineering practice. So it needs a significant cultural shift that has to be adopted by these teams, and that's one of the important mandatory needs for it to be successful or not. So that
yeah.
decides one of the things.
And I
So the
think the
other
point
thing is
point
that
that you mentioned on cultural shift is I think is more relevant for even the smaller companies like the small suppliers, because maybe the bigger suppliers or OEMs have already made that shift, but the small suppliers which do the kind of engineering work for these bigger OEMs still need that shift to be happening.
yes,
Yeah,
because it's a multi-tier ecosystem. It's just not okay if a OEM adopts it or an intermediate tier supplier adopts it, but rest of the ecosystem is not
correct.
actually aligning
Yeah,
to it. So that is going to be a challenge in the roadmap. There are going to be bumps. It's not going to be a smooth journey, but also it gives an opportunity to say, where do we standardize the document exchange? Because even in MBSE, the document exchange and export is still based on standards. So that's
mhm,
evolving, but it's going to an industry-driven standard. So what that helps is that it enables a mix of MBSE and traditional document-centric thing to be mixed and still be used in the life cycle. It could be within the organization or between, let's say, OEM and other tier N suppliers. So it's sort of enabled in that, but you are rightly told, for smaller and medium-sized organizations, it's always a challenge if they start on a low or zero base on this. And yes, obviously, the other thing that's not really evident from MBSE is the initial cost and the efforts in setting up the tooling and the PLM and the adapters, enabling it. If you truly want to have a mature practice, let's say on a scale of 5, which is complete MBSE, right from the design lifecycle up to the product's maintenance lifecycle and production and other things, or on a scale 1, which would be just basic adoption of MBSE or the traditional document-centric thing with a model-driven thing. So in between this, organization could start off on any base, but depending on what maturity level they want to practice, because you won't get down to the highest maturity in one step. So you have a challenge that you need to invest in some of these tools and their ecosystems and how they come together and integrate, Similarly, you need to have engineers to be upskilled and culturally be ready to basically adopt these practices and practice them and see the benefits. And any organization will have to tailor their MBSE practice that suits their need, because there's no one size fits all, and MBSE is not a standard. It's actually a methodology and a practice that they need to institutionalize it as a process in their organization. So that's some of the unknown stuff that if it's better known to the adapter, then they can be aware how do they basically plan and strategize this adoption and rollout. And some of the other things is what are the benefits of it? From an organizational design, it actually enables upskilling of your workforce knowledge and skills. Yeah, that's the upside of it if you do it right. And then it also integrates the different multiple disciplinary teams which are usually siloed. That's the other upside, which can also be a risk if not done right. Same way, this kind of integration and upskilling of knowledge with the current productivity levers has demonstrated tangible benefits to organizations that have adopted this practice in the past 5 to 10 years. And also the organization structure can uh, break down the hierarchy and focus more on integration and actually leveraging both the development and the verification life cycles by adopting DevOps and CI/CD kind of pipelines, which is not possible in the traditional thing. So the MBSE sort of enables that also as part of an organizational ways of working improvement. And the other thing is, uh, obviously, to realize this, the organization has to have enablers around this, or they could even become barriers like uh, planning training for the people upskilling, and also leadership management and support and commitment is absolutely required. Otherwise, it's bound to fail. They have to buy into this vision and they have to see the value in this. It's just not you take a tool and then it just works. It doesn't work like that because it's a significant adoption of a new ways of working or a disruption from the document-centric way. And also you need the right set of resources to enable this infrastructure and also adopt this tool infrastructure and set it in place by piloting them or basically rolling out in phases so that you don't really introduce significant shifts that may really disrupt uh, the organization's uh, ways of working or efficiencies. And obviously the change management is a big challenge. So not just the digital thread or whatever we are talking and the adapters and the process, it also involves defining these methodologies and process and tailoring it for your organization. So that change management needs to be well thought out, defined, and then rolled out in a across the full V life cycle or in parts of it, depending on how they are adapting and rolling it out. And also there should be a clear implementation strategy and design realization using one of the methodologies, because MBSE, some of the popular methodologies are like object-oriented system engineering methodology using SysML. Then you have object process methodology. Then you have rational rope and other kind of practices. So you need to see which of them best suits for your MBSE kind of a life cycle adoption, tailor that process, pilot it, and then institutionalize and roll out. So that's one of the change management principles that organization will have to adopt, and also a strategy towards that. And obviously, as told earlier, also you need to have a cultural shift and an openness to basically see the benefits of this and then adopt it, because there are going to be some ways of working that's going to be new or it's not going to be clear, but with time that basically that familiarity sets in. That's one of the things. And the other important thing is the openness and willingness to really get into this tool ecosystem, because it's more tool centric when compared to a document centric thing, which is all siloed. But when it comes to the integration of tools and visualizing that, some of the times it doesn't really work as smoothly as you plan. But if you do need pilots around the different disciplines, have studies conducted and lessons learned, and then roll out, it really gives you a very clear path to adopting it.
Yeah. Well, thanks for highlighting some of those challenges and the ways to overcome those challenges for these organizations. And you mentioned about some of those organizational enablers. If you talk about, incorporation of new technologies and specifically technology enablers like AI or digital twins, certainly these new technologies are, promising to make MBSE even more powerful tool than what it used to be. But to get the full value from model-based systems engineering, we need to have obviously a unified data environment and ensure models are consistently updated as well as accessible to all the stakeholders, eliminating the data silos, which can be achieved with the digital thread, as you mentioned earlier.
Yes.
So that every modification and requirement is captured and traceable throughout the life cycle. How can A&D companies actually realize the full benefits of this model-based systems engineering? Do we have any particular digital thread specific solution which can integrate these MBSE models with other enterprise systems?
Yes, yeah, that's a neat question actually. To realize the full benefits of MBSE, it can only be realized if the models are synchronized and with other key sources of design and product data. So mainly critical PLM and ALM platforms, they have to come together. They
Yeah.
should have their uh, adapters and other things developed if they are from different vendors, and the ecosystems have to be having clearly well-defined adapters with a methodology that rolls out this process and ties these vendors' tools using these adapters in a seamless way. So this is one
Okay.
of the needs, and also currently in the marketplace with a lot of these PLM and ALM tool providers, there's quite a bit of standardization that is already on the way on this, and the industry is moving towards standards-based exchange and interoperability of these tools. And HCL has been involved with a lot of these PLM and ALM tool vendors, as we are one of the preferred integrators, and we have done for our big OEMs quite a bit of solutions in development of such PLM and ALM adapters, and they have been rolled out. And also HCLTech has been involved in with some of the OEMs in defining and enabling the MBSE process and piloting them and defining with our customers and with the system engineering teams and also across the enterprise engineering teams on how to conceptualize, institutionalize, and roll out the digital threads live in action. And this has been proven on in the past more than 5 to 6 years with several big OEMs in the in the aircraft and defense industry by HCL Tech.
Okay. Sundar, can you maybe share some real world examples of, how MBSE has been successfully implemented by leading A&D companies or the A&D ecosystem, the small companies within the A&D sector? And my follow-up question is, I think you already mentioned about some of our PLM and ALM related capabilities. Maybe can you elaborate on some of those MBSE related HCL Tech capabilities that we have?
Yes, yeah, surely. HCL has been involved across different spectrum of this MBSE ecosystem, as we are told. One is the system engineering aspect of it itself and the multiple disciplinary sides. And this is the system engineering practice side of it. And the other thing is the PLM adapters and the ALM adapters and their integration and process definition and rollout with our customers. So as I told, on the PLM and the ALM connectors, and the rollout of them. We have extensively done this on Siemens Teamcenter and other PLM ecosystems. And on the system engineering practice, so that's where we have differentiated in terms of providing our own in-house solution accelerators in the shift left philosophy. Just to provide a case study is for one of the cargo loading systems for a OEM aircraft manufacturer that we are working on in the past 3 years. We started off with a very small, as I told, low fidelity, medium integrity uh, simulation model
Mhm.
for the cargo loading system. We are responsible for basically doing the high fidelity design models that go into the product later in the cycle. But we had a team who engaged with our customer and customer's customer to basically understand the concepts, build the virtual models, and then basically provide the visualization of that and the behavioral simulation upfront early.
Okay.
And then we were involved in stabilizing them, and then that visualization was demonstrated, fed back, and then this helps in basically refining the ConOps requirements. And as they matured, at some point, somewhere around 12 to 14 months later, there came a point where this model was stopped, and then we switched to basically the design level implementation of the control models. And here we could switch from a specification model meant for virtual simulation and modeling of a low fidelity, medium integrity thing to a design model, which now moved more into the high fidelity and high integrity aspect, including handling of safety scenarios. So this was a case in point, and all this virtually. And now after uh, we are into close to the 30th month of the execution, and now the same design models are being put in the hardware in the loop in a real hardware environment, and they are being tested on the real hardware. So as you can see, this 30 months, which was a shift left philosophy, is a true proven case in point where we were able to first do the prototyping, do the behavioral modeling, exactly like what we told in the MBSE, and this is an actual project on which it's being done. And now it's reached a stage of maturity where the design models, the code have been generated, loaded on the targets, and now it's still running in the simulation for the plant models, but the control model is actually running the one that's going to be loaded on the aircraft. So this is a classic case study of a system engineering practice from a V&V support from our side, from HCL side, from a verification and validation, and also system simulation capability. The other thing we have done is that we have also done pilots and a process, lightweight process methodology using the object-oriented system engineering methodology, which uses the SysML as a practice. So this is targeted more for customers who are small or medium organizations who have a low base of knowledge on MBSE and just to jumpstart that. So we have that methodology of practice that helps them instead of just telling what MBSE is, we can handhold them and then jumpstart on some development. And this was
Yeah.
done as a pilot from our end, from a process institutionalization, and HCL being a CMMI level 5 company in terms of process maturity and other things. These are one of the things that independent of the product, do we have a process capability that we can go out and tell, yeah, this is what our maturity level is, and if you want to adopt this practice. Whereas the bigger organizations, they come with their own methodology, their own process, where again our teams have been co-located with our customer teams, and we have fully defined the enterprise-wide frameworks working with the customer teams. So that sort of gives you a broad-based understanding of what have we actually developed and supported and deployed in terms of MBSE practice across HCLTech as a system engineering practice.
And from a tools perspective, Sundar, I believe our capability spans across most of the major providers of these tools and solutions, right?
Yes,
In terms
that
of
is
the
right.
MBSE tools, yeah.
Yes, so some of the popular MBSE tools are the System Modeler from Cameo or Dassault Systems. Then we have from PTC and also from IBM, the Rational sort of thing. So we have been practicing and we are very competent in use of these tools and adopting the SysML based project definitions or project management of this MBSE models using these tools. And also on the PLM tools, as I told, we have extensive experience working across different tools from the mechanical domains from vendors like ANSYS, Dassault, and also from MathWorks, and also the ECAD simulations tools from the hardware and firmware groups. So we have a plethora of products or tools for which adapters have been done, and then they can actually talk to each other, and all the engineering ecosystem sort of binds in to the digital thread. That's
Sure.
been the experience of HCL.
Great. Well, thanks, Sundar, for those wonderful insights on model-based systems engineering. I think this was a very fantastic session and great speaking with you. Thanks a lot.
Okay. Yeah, thank you, Anshul, and it's been a pleasure talking to you. See you. Thank you.
Thanks. Thank you.
Bye.